Hello. So we are going to prove that alpha equals beta by 2 equals gamma by 3. And for that we have taken three figures here. The first one is a one-dimensional figure, the second one is a two-dimensional figure, and the third one is obviously a third-dimensional figure. The first one is a simple rod and it has only a length. It might look like it has a breadth, but please ignore that. It just has a length, okay? It just has a length. We are just going to work on the length in this case. So let's consider that the initial length of the rod be L0, and this is a square here, and let us consider that this side and this side both are equal to L0 as well, because we need that to do this proof. And for the volume of this cube, we can also say that each edge of the cube is equal to L0 as well. So this and of course this are equal to L0, and we know that the area of the square, let us consider the initial area, was A0, and we know that the initial volume of this cube was V0. We are assuming this, okay? We are assuming this. Now, let us start with this rod here first, and let's work our way up. Okay. First, we need to write that, let's consider that the final length after expansion of this rod will be just L. That's a big fat L. Okay. L equals, this is the final length, L equals L0 1 plus alpha delta t. We know this from the coefficient of linear expansion. I am assuming that you know this since you're doing this proof, and if you don't, I recommend you go and watch out how we got to this thing, because I'm not going to make this video long, and we need to remember this thing. We are going to use this entire thing for this entire proof. This is the main thing here. Remember that. Okay, remember that. So let me erase this now, and I'm just gonna write this as a short, really short up here. L equals L0 1 plus alpha delta t. Now I'm just gonna write it up here. Now let's go to the second one, because this one is going to stay unchanged, and I'm just going to term that as 1. Okay, for the second one, we see that we need to work with superficial expansion because it is a square. It has two sides, length, although it has length and breadth, but in this case both are equal, so we're going to consider both of them to be length, and we know that each side is equal to the length of this rod, which is also L0. So we can assume that the final area of this square is going to be A. Okay, A equals A0 1 plus beta delta t. We already know that from coefficient of superficial expansion, but we also know that area is equal to L square, right? We know that. So we can write here that L square is equal to A0 1 plus beta delta t. That's t, okay, that's t. Anyways, and we can replace the value of this L from this, and we can also write that L0 is equal to L0 1 plus alpha delta t is equal to L, so we can write L0 square 1 plus alpha delta t square is equal to whatever was here. So, but I'm going to directly replace the value of A0 we know that A naught is equal to L0 into L0. So we're going to write here L naught square 1 plus beta delta t. Obviously we can cut from here, we can cancel them out, and we have left here you can see this is a plus b whole square's formula, so we can write 1 plus alpha square delta t square equals 1 plus beta delta t. Now 1 is going to get cancelled, and we can also write, oh, I missed a formula, my bad, plus 2 alpha delta t. How could I miss that? Yeah, that's the main thing. Okay, so here this alpha square delta t square, this thing's value is going to be very less than 2 alpha delta t, so we can neglect the value of alpha square delta t square. We can neglect it, and we can write 2 alpha delta t is equal to beta delta t. Delta t will get cancelled, and alpha is equal to beta by 2. So we got the first part of the equation, which is the second part, sorry. And now we just need to prove the third part, that alpha equals gamma by 3. So I hope you understand this gibberish mess over here, because I explained it. And now I'm going to move on to the gamma part. Now we are going to keep this thing here, because that's the main thing which we are going to use as the base for proving this entire thing. Alright, so for the last one we can see that final volume equals volume naught V naught 1 plus gamma delta T. Similarly, we know that volume is equal to the cube of length, so we can write that here again, that L cube is equal to V naught 1 plus gamma delta T. Now we are going to replace the value of L with this, but we are also going to replace the value of this with L naught square or L naught cube. So just look at what I do. So we're going to do L naught cube 1 plus alpha delta T whole cube is equal to L naught cube 1 plus gamma delta T. This will get cancelled, and we are left with 1 plus alpha delta T whole cube equals 1 plus gamma delta T. Now of course we are going to put a plus b whole cube formula here, which is going to be a cube plus b cube plus 3a square, 1 square is 1, b plus 3ab square. So 1 is going to stay 1, so 3 alpha square delta t square equals this side 1 plus gamma delta t. So we can cut the 1 from this side and this side, and we are going to be left with alpha cube delta t cube. Okay, so again in this case, like the last one, this and this alpha cube delta t cube and 3 alpha square delta square, the combined sum of both of them is going to be much less than 3 alpha delta t. So we are going to neglect their values here. So we're going to write 3 alpha delta t equals gamma delta t. Delta t will get cancelled out, thus alpha equals gamma by 3. And from this, finally, we can write that alpha equals beta by 2 equals gamma by 3. Proved! So let's go. Hopefully this video helped you. I'm gonna meet you next time.